Welcome to my YouTube channel once again. Today, in this video, we are going to discuss about the problems which are not yet solved. Okay, so we discussed about FLT, Fermat's last theorem, but the proof is so complex that we are actually trying to prove in a simple mathematical, arithmetical, using number theory basically. Okay. And then we also discussed about perfect numbers, especially whether any odd perfect number exists. Okay, so far we know that there is no odd perfect number, but we still have to prove that if at all perfect number exists, then that should be even. Okay, so apart from this, we will discuss about GoldBach conjecture. So what GoldBach conjecture says is that if I have any even number apart from 4, in fact including 4 actually, so it is the sum of two prime numbers. Okay, so 3 plus 3, let us say next even number is 8. 8 is 5 plus 3, 10, 5 plus 5, or 7 plus 3, so on. So far we have checked, people have checked that take any big amount of take largest even number so far, and then see that whether it's a it's sum of two primes. Yes, so far million digit, I don't know million digit or trillion digit, but there is a so far every even number within the human range is sum of two primes. Okay, all right, so the proofs which we discussed so far, they are incomplete. Okay, the reason why I have put them in these videos is that every time what happens generally is that any mathematician, okay, he tries to solve it using in his notepad or in his notebook, and then he will only publish success if at all. For example, Andrew Wells proved that FLT, and he did not, we don't know how many attempts he made to solve this problem, but final version is that there is a one PDF which proves FLT beyond any doubt. Okay, so then again, perfect number. People try to prove the perfect number, odd perfect number. Okay, similarly, people try to prove GoldBach conjecture. There is a movie on this. It's called Fermat's Room. Okay, somebody claims that he solved the problem and then gets famous. He becomes famous. Then again, somebody else who is trying to, who was trying to solve the problem gets jealous of this guy who solved the problem and then, tries to kill him using Fermat's, logic. Fermat's loom actually. It's like he designs a room so that he gets trapped into it. So the idea is that so far nobody actually solved the GoldBach conjecture. We know that every even number is sum of two primes, but there is no proof of why it is so. Okay, so okay, all right. So the why I have listed these three problems, because there are so many unsolved problems. Okay, at any point of time. Okay, at any given point of time, there are more unsolved problems than solved problems. Okay, so but we cannot list all the unsolved problems. Okay, so what we list is the basic unsolved problems, the problems which we understand. At least some of the school mathematicians, school mathematicians or YouTube mathematicians, we understand it. We understand these problems. These are the problems. We understand the problems. We don't know solution. Okay, we understand the problems. Okay, there are so many problems which I don't understand. Okay, you try to understand it. You please go ahead. But these are the things, conjecture. I understand. I understand that. Okay, every even number can be written as sum of two primes. Okay, I understand that. Similarly, I understand perfect number. If a number is sum of its factors, it's a perfect number. So far, I try to find odd perfect number. No. So far, every even number. I mean, whatever the perfect numbers is we found. I mean, we found through books. It is only even. Similarly, I mean, at least nobody could find a cube plus b cube is equal to c cube, any integers. Okay. Ramanujan found one number, magic number 1729. But it is very close to this. But there is a difference of 1 here. And then it is very easy. Here it is like, okay, these two are not primes, co-primes. Okay, if at all a cube plus b cube is equal to c cube, ABC should be co-prime. Okay, here 9 and 12, they have 3 as a common factor. But still, it is very close. What Ramanujan said is that there are other numbers which satisfy this. I mean, it can be expressed like a cube plus b cube is equal to c cube plus d cube. But he never said you can find a cube plus b cube is equal to c cube. What he said is that if you take two separate integers, and then cubes, you can have this combination. This is the smallest such combination. Okay, that means there are other higher numbers which satisfy this equation. All right, we don't know that. Okay, so we will try to derive that also, whether we can actually derive higher numbers than this. All right, next. Okay, so why I listed all this? Okay, so now even though we can't find a cube plus b cube is equal to c cube, we already found Pythagorean triplets a square plus b square is equal to c square. Okay, that means that Fermat's theorem or last theorem says that you cannot find more than 2. I mean, you cannot find a cube plus b cube is equal to c cube, a power b power c power 4. But we already found this, right? The only addition is that you cannot find a plus b, b power p, c power p. P is greater than 2. So there is please note down there is a 2 here. Okay. All right. So Fermat's. So if at all you have a square plus b square is equal to not c square, then Fermat's last theorem would have said, only you can find a plus b is equal to c. Sum of two numbers is another integer. Sum of two integers is another integer, but you can't find this. Okay, so but still we have Pythagorean triplets. Okay, the proof of Pythagorean triplets, we discussed this in our previous videos. Please watch out. If you have any doubt, there is a formula for this. There are so many Pythagorean triplets, infinite Pythagorean triplets, by the way. Okay, perfect number. Perfect number also involves 2. So if the number 2 power p minus 1, if this is a prime, perfect number is this format. So again, 2 is the major factor. In Fermat's last theorem also, 2 is the major factor. I mean, we can always find a square plus b square c square. Okay. All right. So if at all you can find perfect numbers, there should be multiple of 2. There is the format like you can always find. These are the exceptions. Okay. Square plus b square 2. We proved this. Okay. We have seen this in our previous videos that perfect number is of this formula. We actually can derive this also. All right. So Goldbach conjecture says every even number. What is even number? Is actually even number is 2 multiple and also sum of 2 primes. Okay, so except 4 is the only even number which will have 2 sum of 2's. 2 is also prime number, by the way. Okay, so apart from this, everything else is kind of a sum of 2 odd prime numbers, because every prime number other than 2 is odd. So odd plus odd is even. Okay, so these are the basic rules, like odd plus odd is even plus odd is odd. You know, these are the basic rules which we have at our disposal. Okay, so now here Fermat's last theorem says that apart from 2, everything else is true. Okay, there you cannot find anything else, higher powers. Here perfect number says if the perfect number exists, it should have this format. There is no other form of perfect number. So far we did not find anything. Okay, Goldbach says every even number is sum of 2 primes. So the link between these three, these unsolved problems or whatever, is actually 2. Okay, so that means that 2 is something like a magical number. Okay, so now why we are not able to prove? Okay, so far why we are not able to prove these conjectures to perfect number or FLT through number theory. So it was proved geometrically, modularity, I don't know. There are higher terms actually. Sorry. Okay, so I'm sorry. I know only basics. I know only integers or number theory. Even I don't know that, but still I can understand number theory. But I don't know anything else. So I'm trying to prove that within number theory, within integers or numbers, we try to prove this, or if at all we say that okay, there is no proof, we should also prove that there is no proof. It is like Kurt Gödel's statement, right? There are truths which are unprovable. Okay, so in any given system we have some statements where like this which are unprovable. Even if it falls in that category, there is no doubt. Okay, we should prove that actually these statements, these conjectures are beyond our proof. Okay, for example, minus into minus plus. Okay, you can do a lot of interpretations, right? Minus into minus is plus. Then this implies I is equal to imaginary number equal to -1, real number. Okay, so since there is no square root for any negative number, because minus into minus plus, so that means that we should have imaginary number where imaginary number square is -1. So even this is an interpretation, right? These are not actually, so we should take them at face value and then proceed with that. We can't ask for proof. Okay, so and then Goldbach conjecture. Goldbach conjecture, can we take it as as a statement which we can't prove and then go ahead? We don't know. So either we should prove that there is no proof, either we should prove that this is it, or we should prove that these are the truths, accept it, and then we cannot prove it. So, and then the link between these three is actually 2. So is that we are missing some fundamental mathematics than whatever we know? Is there any rule higher, I mean, something like more fundamental than this. And then from where we are actually deriving FLT, and we can actually derive perfect number. We can also prove that GoldBach conjecture from that rule, fundamental rule. Yes, the next video is that to understand the more basic formula than any of this, whatever we are attempting, because we are attempting infinite practical equation. I mean, the proof is actually infinite. So we are not going anywhere there. Okay, at the same time, if we don't attempt that, we don't know that we are going to hit the roadblock. So please watch out for my next video on this. Okay, and then we're going to prove at least that we can prove. As simple as that. Thank you very much.